Hello and welcome to Funda of Mechanical Engineering on YouTube. This is Deepak Sharma here, and today I'm trying to make you understand the concept of isothermal transformation diagram, originally known as triple T diagram or Benz curve. Okay, so before knowing the triple T diagram, you will need to know some basic concept or basic terminology of material science of iron carbon equilibrium diagram. Okay, so let me first tell you definition of what we call isothermal transformation diagram or triple T diagram. Here triple T stand for time, temperature and transformation. Okay, time, temperature, transformation diagram or Benz curve. So definition can be given as isothermal transformation diagrams, also known as time, temperature, transformation diagrams, are plots of temperature versus time, usually on a logarithmic scale. They are generated from a percentage transformation versus time measurements and are useful for understanding the transformation of an alloy still at elevated temperature. You think, oh, I am telling the only bookish definition, it is not still clear to you. I know it is not still clear to you, because for getting better understanding, for getting proper exact concept of triple T diagram, you will have to watch this video up to the end. Okay, so that I can explain each and every term. What is logarithmic scale, temperature versus alloy steel, I will explain everything in this diagram. So I want you to watch this video up to the end. Okay, so let me first go through the basic terminology, basic terms that we must know before getting concept of triple T diagram. Okay, there are some basic terminology here, and I'm telling you one by one. Okay, first one is incubation period. We will have to know what is incubation period. When quenching austenite is a allotropic form of iron. In iron carbon equilibrium diagram, I have already explained that what is austenite is gamma austenite. Okay, is abscissine crystal structure. When quenching austenites below 725 degrees centigrade, it was observed that for substantial period of time there was no change in the microstructure. This period is called incubation period. You're thinking, oh, what is quenching? What is quenching? What is tempering, annealing? Everything I will explain in this video. Okay, so don't have to worry about with any words. Okay, so let me first tell you overall briefly, then I will explain every term. Okay, incubation period, there is not a better term. You will have to always keep in mind that incubation period decreases as the temperature of quenching decreases. Okay, temperature of quenching, as soon as temperature of quenching decreases, incubation period will also decrease. Okay, next important term is annealing. What is annealing means? Actually, if you have to keep in your memory, that simply take annealing means softening something. Okay, so in annealing process, what happened actually, austenite by furnace cooling. Okay, austenite, gamma austenite is transformed into coarse perlite. Okay, by doing furnace cooling. Okay, if we will do the furnace cooling of gamma austenite, then it will be slowly cooled down and it will transform into coarse perlite. This process is known as, or this transformation is known as annealing. Okay, then what is normalizing? Simple way to keep in mind normalizing, make normal. Make normal means there is no need of oven or furnace for cooling. That means gamma austenite is directly transformed into fine perlite. Okay, whose grain is very fine, that's why we call it as a fine perlite, by doing air cooling. Okay, we do not need any furnace cooling or oven cooling like annealing. In normalizing, simply normal austenite is transformed into fine perlite by doing air cooling, and it is much faster than annealing. Why it is much faster? Because we know this here in annealing we are doing furnace cooling, but in normalizing we are doing air cooling. Okay, and next term is terminology. In terminology, next term is austampering. Austampering means what? Austenite is directly transformed into bainite by heating it into austenitic region. Okay, so is austenite is in heating directly convert into bainite. Okay, and what there is not a beta term in austampering that tentative to harden a metal and produce a stronger microstructure by hitting it into the austenite region and then immediately quenching and removing any bainite and austenite. Okay, so here now I think it is very clear to you what is incubation period, what is annealing, what is normalizing, what is austampering. Okay, austampering, austenite is transformed into bainite by hitting it into austenitic region. And last but not least is quenching and hardening. What is quenching? You know, quench is getting thirst. Okay, and try to remove the thirst. Okay, so quenching means giving something cooling, uniform cooling to any body. Okay, so in quenching and hardening, austenite is directly converted into martensite by doing uniform cooling. And how we can do the uniform cooling? By oil bath you can do the uniform cooling. So there is not a bit of term in quenching and hardening that martensite quenching is obtained. In quenching, uniform cooling is obtained by oil bath. Okay, and these are the important points that I will describe it later. Let me show you in a graph that what is incubation, what is annealing, what is normalizing, what is austampering, what is quenching and hardening. Let me show you in triple T diagram. Then I will discuss triple T diagram in very brief, in details. Okay, not in brief but in details. So let me first show you. This is triple T diagram for 0.8% carbon of steel. Okay, this is triple T diagram for 0.8% carbon of steel. So here is the 7 to 5 degrees centigrade. This temperature is called eutectoid temperature. Okay, and if the following line represents the different process, this line, this dotted line, this dotted line, this dotted line, and these two red color lines. First red color, this line represents, this color red lines represents nucleation curve. Okay, or represents the nucleation rate, and this curve is known as nucleation curve. And second red color line is pink, actually is known as growth curve. Okay, or growth rate. This represents growth rate and this represents nucleation rate. From the picture it is very clear that nucleation rate is higher than the growth rate. That's why it is just forward from the or ahead of the growth rate curve. Okay, and this temperature is eutectoid temperature. And see, from the eutectoid temperature we are doing slow cooling. Just temperature is decreasing slightly by oven cooling or furnace cooling, and as a result what produce? Quartz perlite. In annealing, quartz perlite produce, I have told you already earlier, and this process is annealing. This process is very slow process. And now if we do the air cooling, that means there is random cooling. Okay, air cooling, normalizing. So this along this line, this green color dotted line represents the normalizing, and this is much faster than annealing, and it will produce fine perlite. Okay, and as I have as it is clear from the diagram that this is gamma austenite region, this is perlite zone. What is actually perlite? This is alpha ferrite plus cementite. What is perlite? Perlite means is the combination of alpha ferrite plus cementite. I have already explained these things in my iron carbon equilibrium diagram lecture. Okay, and this region, Massey zone, this region is the region of gamma austenite plus perlite. Okay, so this is gamma austenite plus perlite zone, this is austenite zone, this is perlite zone. Okay, and there is a normalizing is already over, annealing is over, and there is a bainite. We do the cooling, and suddenly we do, if any process will occur in this way, then this process is known as bainite or austampering. Okay, process is not known as actually bainite. If any process will occur through this path, then this process is known as austampering, and result produced bainite. Okay, and if from this point this process is extended continuously up to 270 degrees temperature, then martensite, quenching and hardening process starts. That means at 270 degrees centigrade martensite start and 120 degrees centigrade martensite finished. Okay, so and this process is known as quenching and hardening. So what is austemperering? This line represents austemperering, this line represents normalizing, this line represents annealing, and this line represents quenching and hardening. What is martensite? So everything is now clear to you, and this is triple T diagram. Before telling you triple T diagram, let me tell you it is the diagram of temperature versus time, okay, or percentage of decomposition versus time. I will explain everything, just wait for a moment. Then I will do the study of isothermal transformation of austenite considering eutectoid 0.8% carbon composition. Okay, so for getting exact and proper concept, watch this video up to the end. Now let's do the study of also a triple T diagram for 0.8% carbon composition of steel. Okay, and diagram is here. Got it to you. Yeah. So this is triple T diagram for 0.8% carbon composition of steel, and I'm going to, and this diagram represents, this diagram is known as triple T diagram. What is this, and what is that? I will explain everything as from the previous diagram. You know, this is nucleation curve. This line represents nucleation rate. This line represents growth rate. Okay, and this temperature is known as eutectoid temperature, and growth rate, after growth rate curve, this austenite is transformed into perlite. So that's why this curve is also known as completion curve, and at 250 degree temperature martensite start, and at 20 or 110 degrees centigrade martensite finish. Okay, so let's have a study of isothermal transformation of austenite considering eutectoid 0.8% carbon composition, or triple T diagram. Okay, so let me tell you, small specimen of steels are heated to temperature corresponding to existence of austenite, that is above 7 to 7 degrees centigrade or 7 to 5 degrees centigrade, are rapidly cooled, super cooled to temperature below 650 degrees centigrade, 500 degrees centigrade, 400 degrees centigrade, and 250 degrees centigrade, etc., and held at this temperature until the austenite is completely transformed into ferrite cementite conglomerate. Their completion is determined through the microscope or diameter. Okay, so what I'm trying to say, that at 7 to 5 degrees centigrade austenite is cooled at different temperature like 650, 500, 400, and 250 degrees centigrade, and this austenite is transformed into perlite at different temperature. Okay, and this completion is also determined by some engineering instrument like microscope and diameter. Okay, now the plotting of such curves based on cooling to various temperature like 650 degrees centigrade, 500 degrees centigrade, 400 degrees centigrade, 400 degrees centigrade, and 250 degrees centigrade enables an isothermal austenite transformation, that is triple T diagram, time temperature transformation diagram, and following this is triple T diagram is constructed. How triple T diagram is constructed? This is done by plotting the length of the time corresponding to the beginning and end of the austenite decomposition. Okay, so this is the beginning of the decomposition, this is end of the composition. Okay, and temperature along the axis of the ordinate. So this is the ordinate and temperature along the axis of the ordinate. So this line represents temperature, this line represents percentage of decomposition, this is start of decomposition, and this is finish of decomposition, and this line represents the time. That's why time, temperature, and transformation. Okay, transformation is take place. So time, temperature, and transformation. That's why we call it as a triple T diagram. Okay. Then after knowing the point of starting point of decomposition and finish point of decomposition, then what we do, then points of decomposition of starting and points of decomposition of finishing are joined by smooth curve. This is smooth curve. This smooth curve is known as S curve, and below this curve is known as C curve. Okay, the bottom curve is known as C curve and the top curve is known as S curve. Okay, no austenite decomposition is experimentally observed during a certain interval of time, S1, S2, etc. This time is called incubation period. I have already explained what is incubation period. There will be no any transformation during such period. Okay, that's why no austenite decomposition is experimentally observed during a certain interval of time, S1, S2, S3, S4. Okay, that's why this time is called incubation period, and this is the time of diffusion for decomposition. Okay, this is the time for diffusion for decomposition. That's why this period is called as incubation there, because there is no transformation occurs at that time. Okay, austenite stability is greater at 700 degrees centigrade. Okay, austenite stability is greater at 700 degrees centigrade. Then reduced come to minimum stability at 500 degrees centigrade. Okay, nose to the curve. See, this is nose to the curve and temperature is 500 degrees centigrade. And again stability increases as the temperature decreases. That means it is austenite is more stable at about 700 degrees centigrade, and its stability is decreases near about 500 degrees centigrade, and again stability decreases as the temperature decreases. Again stability increases as the temperature decreases. So this is all about triple T diagram. This is S curve, this is C curve, and how it is constructed, what is normalizing, what is annealing, what is coarse perlite, what is fine perlite, what is osteompering, quenching and hardening. These things I explain in this diagram, and if these all things are clear to you, then you will be easily able to explain what is triple T diagram and why we call it as a triple T diagram. So let me tell you some important points regarding triple T diagram. I already explained quenching, hardening, and so an isothermal transformation diagram is only valid for specific composition of material. That is, it is only valid for specific composition of material, and only if the temperature is held constant throughout the transformation. It is very clear, and strictly with the rapid cooling to that temperature. Okay, though usually used to represent transformation kinetics for steel, they also can be used to describe the kinetics of crystallization in ceramic and other materials. Time temperature precipitation diagram or time temperature embrittlement diagram have also been used to represent kinetic changes in steel. Isothermal transformation IT or triple T diagram or C curve associated with mechanical property, micro constituents or microstructure, and heat treatments in carbon steel diffusion transformation like austenite transforming to cementite and ferrite mixture can be explained using the sigmoidal curve as I have explained in this curve. Okay, so friends, this is all about triple T diagram. If you like my videos, then please do not forget to subscribe my channel, which is Fund of Mechanical Engineering. Insert more and more so that I can make you more tutorial videos for you or for getting better concept of mechanical engineering subject. Till now, thank you so much.